All right. Excellent. Well, thanks everybody for being here. Thanks for paying attention and sticking so long. So I want to talk to you about communication of zero lower bound. Now, this will be, if you will, a policy discussion, a bit more on the theoretical side. And we'll think about what's the point of forward guidance at all. Now, we all know since the Great Recession, we've been at the zero lower bound, which of course prevents the standard accommodation of shocks that central banks have at that level. Now, we have many unconventional policies. One of them is forward guidance, just to be clear, announcements about the future path of the interest rate. So why do we use it? Well, there are a couple of consensuses in the literature. The first one is, of course, commitment. We promise to keep interest rates lower than otherwise optimal. And I guess Egerton, Woodford, and perhaps even Krugman before started this literature. Now, there are also problems with this view. One is time inconsistent. As we saw in Ty's presentation earlier, the central bank has an incentive to renege when the stimulus has already been delivered and they're promising a boom, but at that point they're saying, you know what, we'll just keep interest rates where they are. And also, central bankers say that's not what we do. We don't like to tie the hands of the next committee, and we don't really promise. So in our communications, we don't really commit all that much as the theoretical literature views. So there's the second view, which is that forward guidance is more of a communication device. That the central bank has superior information on perhaps private information, and that's supported empirically to some extent. However, we have a bit of a lack of models of modeling how does that communication work then. And you can see Campbell and others for the Delphic versus the Odyssean classification. Now, one thing to say is, well, what if policy changed? What if the zero lower bound was such a period that we had a policy change? And actually, I do have a paper on that where I considered policy change and how forward guidance could be interpreted differently, how people weigh the two Taylor coefficients, and so on and so forth. But spinning out of that paper, I actually want to show that the zero lower bound itself, under some, of course, conditions, which might be strong, is that it causes disagreement, and disagreement between the central bank's expectation and the market's expectation. I won't be talking about dispersion, so disagreement within the market, that's of course very, very important, but I'll take the central bank and the agents and see how they disagree about the path of the interest rate. So crucially, that's what we'll be talking about today. And there won't be any preference changes of the central bank. So the Taylor rule stays exactly the same. And yet the agents disagree with the bank. So what?
Sorry, Viktor.
Yeah.
What about what some people call the conditional forward guidance, meaning you will change once unemployment falls below a certain rate?
I think that's a good question. I think that's very, very important in the real sense. In the model, I guess you could always map a condition to a time period, because when the agents run forecasts of output gap, of inflation, of unemployment, of earnings, whatever, they can always see, okay, it's about that point. So in a very technical way, as you will see just how they run their expectations, a trigger forward guidance, so which one has like a trigger or a bound, could always be translated into a period forward guidance. But your point is very important in the sense that, as we all know, the Fed and other banks evolve the forward guidance from a really vague to a period to a threshold one. And that specificity has an effect. So the more specific it is, the better it's interpreted. In this paper, I'll be considering a very simple forward guidance, which is completely believed. There won't be anything strategic. I think it's very important. You've already showed us something about the strategic part. And as I said in a different paper, I consider the credibility of the message, how they interpret it, how clear is it, and so on and so forth. But here, the focus will be on the disagreement, and the forward guidance will be very simple. All right, so the structure of the paper is we have agents learning about the data generating process. So we have adaptive learners, very standard in the literature, and in a very standard New Keynesian model. The key component here is that the zero lower bound acts as an informational curtain. Essentially, it's censoring the data for the learners, because the learners, they observe the interest rate and they update their matrix from it. However, once you censor it, they don't see the movements of the shadow rate. which means they lose the signal at least in that period. Now I go to lend, trying to make them as clever as possible, and yet that causes a problem. And forward guidance here will be a communication device, nothing strategic. So the main results of the paper are: first, the zero lower bound plus learners in the economy means that inactive policy causes different propagation of shocks. That's kind of the zero lower bound bit. And that's not very surprising. We know that once the interest rate is not responsive to shocks, they hit harder, if you will. However, I show that this causes a disagreement between the central bank, which is assumed to have model consistent expectations, and the agents who have econometric learning expectations. And that gives us a row for forward guidance, just on the basis of why should we do it at all if we're not committing. Commitment might be an important story, but I argue there's something to say about just the informational aspect of it. Now, second, which I think is also very important, interesting, is that if you don't communicate at the zero lower bound, the system becomes unstable. And that's the learning literature has established that an interest rate peg, which the zero lower bound is non-stable, so it's not learnable. However, it's one thing to see that actually numerically, when you run the simulations, the forward guidance message can contain the expectational drift and can restore stability to a large extent. I'm still working on the exact heat maps and numbers, but that is a robust result that yes, the zero lower bound can cause instability. You see exactly how, but the forward guidance message keeps expectations in check such that we still resume the system despite the non-linearity of the zero lower bound. Any questions before I go on?
No, I actually like your paper because my very first paper was sort of on this topic. Right. I wrote it in 2010 with Basit Zafar, and it was actually about expectations disagreement and the persistence and the anchoring of inflation expectations in households. But when we wrote the paper in 2010, there were no worries about forward guidance and things like that. So we weren't even thinking about such things then.
Yeah, I mean, you weren't alone, that's for sure. But that sounds very interesting. I'll be very happy to check it out. Yeah. Okay, so let me give you some broad motivation. Now, it wouldn't be anywhere near to Laura's exquisite empirical analysis, but let me show you some. So this is all data from the Green Book. I'm still trying to get all the numbers instead of the graphs, but it's a bit hard. So if somebody has advice how to get the Green Book data for interest rates, I'm very, very grateful. So, all right, what we see in the black line is the Green Book federal funds rate. So this is all federal funds rate. The red line is the market. And what we see is the market expects, that's late 2007, so the beginning of 2008. The market still expects, what's that, 6 quarters in the future, an earlier liftoff than the bank. Now, if we keep on moving, we see same thing happening at the end of 2008, and we move all the way to the end of 2010. We've already received some forward guidance messages. We still, the market is still above the central bank expectation for the federal funds rate. And now when we move, I think that is mid 2013 down at the left, forward guidance has already been received. I think it's much more precise at that point. So you can see expectations have converged, still a bit of disagreement there. Once we're out of the zero lower bound at the end of 2014, essentially expectations of the bank and the agents coincide. Now, so the Fed does this. I mean, they started, I think, 2006 or 7, releasing their federal funds rate forecast. But a bank that's been doing it for a really long time is the Riksbank, so the Swedish central bank. And here's analogous data for the Swedish central bank. And what they do is they release them every quarter, just like the Fed started at in the Green Book, but they're more explicit. Obviously, they are well received, while the Green Book is a bit of a specialist source. So what we see here in the dashed line is what the bank expects, and the dots are what the market expects. Again, once the zero lower bound is binding, we see that there is disagreement such that the agents expect an early liftoff. If we move out of the zero lower bound, they coincide. So that's late 2010 for Sweden at least. Now, the cool thing about Sweden is that they dipped twice at the zero lower bound. Now, granted, the whole world did now, but they did it in 2015. So we do have a bit more data to study. And just real quickly here, you can ignore the bottom line, the bottom panel. The difference is, how do you define low or high? Is it based on the bank's expectation? Is it based on the market? But the idea is the same. So if you just look at the top, in this column where it says mean, this is the mean disagreement between the bank and the agents in a low regime when the zero lower bound is binding, or in a high regime where it's not. And these are the quarters that we have in the between 2007 and 2018, I think, there. And what we see is that in a low regime, the agents always expect an early liftoff. This is essentially the central bank minus the interest rate expected by the bank minus the interest rate expected by the market. If it's negative, it means the agents expect an early liftoff.
Sorry, Viktor.
Yeah.
And why not consider also Japan, that has been facing it for a few decades?
No, absolutely, yes. I should. It was just that this data was easier to access, but I'm definitely, there's something I really want to work on, the expectations and just the evidence. So I totally agree. I should look at Japan as well. Actually, the Bank of Norway, if you will, New Zealand as well, these interesting banks, because they also release such forecasts on a regular basis. Yeah. All right. So let me jump to the model. Yeah.
Can I say one thing? So in the previous graph, the one with the green book forecasts, you had the third one where you had the model rate.
Yeah.
And I think it's when you are in a zero lower bound, the model rate is gives you more information, because the expected value is if you have a truncated distribution, the expected value is farther off than the modes.
Sorry, well, you said the model rate. What do you mean, the market or the banks?
This is the market, right? In the third graph, you have the model rate, which is lower.
So the black line here, let me see.
The dotted red line.
The model. Oh, I see what you're saying. Yes, I see what you're saying. Yeah.
Yeah. So have you had any thought about that?
I actually haven't. I do agree with you. Yes, that the truncated distribution is something to consider. Could you elaborate a little bit what exactly you mean?
Well, this literature about these shadow rate and structure models, they are all about this mode of the future interest rates as opposed to the expectation. And the thing is that when you have truncated distribution, the expectation is farther off than the peak than you have on your distribution. So, so the mode is going to be lower. So I was wondering if, since I've seen it in this graph, if somehow they started publishing model survey expectations or green book forecasts. So yeah, because it makes sense at the lower bound to look at that.
Yeah, I have not looked at that. I should. That's an interesting point indeed. Yeah. The thing is that they, as I said, I have to still figure out exactly how they publish their data, because every PDF is different. Every year they
it is not present before, it's just in this graph.
Yeah, that's the thing. Yeah, I mean, I've skipped some years because in some years they don't even put the market and so on and so forth. Yeah, but once I get the actual numerical data for the Green Book federal funds rate forecasts, I'll be very happy to revisit those. Yeah. Okay. All right. So the model, as I said, it will be a very simple model. We have a canonical three-equation New Keynesian model with adaptive learners. Now, what does that mean? It means that these agents, they observe the data, they have some coefficients in mind which map, as you see just here, which map the exogenous shocks to the endogenous variables, this phi matrix, and they update it all the time. But the thing to keep in mind is that this breaks the law of iterated expectations, and you can go to Bruce Preston and Stefano Zeppi. They have a lot of papers on that topic, which show that your familiar IS curve and Phillips curve, they're not recursive anymore. So you need to keep track of the infinite sum of expectations. Now, that's a bit tedious, but it's also good because it allows us to put the zero lower bound in the expectations of these learners, because I can say, look, they know that from some period M to some period N, the zero lower bound will be binding. So they can forecast the shadow rate just like Laura showed in her paper, but they can truncate it at the zero lower bound, and I can incorporate that. So they're not completely ignorant of the zero lower bound in that sense. All right, so let's see how the whole thing plays out. So this is our IS curve, this is our Phillips curve. We have the two shocks. Everything is very standard. Now, the monetary policy is just a Taylor rule, but crucially, it has inertia, it has smoothing. Why is that crucial? Well, because it makes the lagged interest rate a state variable, meaning it's something that the agents have to keep in mind when forecasting. Now, what the bank does to formulate this interest rate is they observe the expectations of the agents, which is this fancy E here with a hat. So they observe expectations of output gap, of interest rate, of inflation. I assume the shocks are completely observable by everybody and they know their autoregressive coefficient. That's just a simplifying assumption. But the bank observes the expectations, plugs them into the actual model, and then gets these two variables, the output gap and inflation, applies its Taylor rule, and again, just applies, it kind of forecasts the shadow rate and then applies the zero lower bound over it. Now the forward guidance, yeah.
I don't know if it's interesting for everybody, but could you go in a little bit more detail about how you calculate the expectations? Like one period ahead expectations are just basically their perceived flow of motion, and then two periods ahead is I guess an iteration of that. But how do you then take account of the forward guidance messages?
Right. So let me do that now. So as I said, the expectations are the agents observe the state variables, obviously. They also observe the shocks. They know how these shocks, the autoregressive coefficient. So the exogenous variables, they have no problem keeping track of, as does the bank. And this is our expectational matrix. So what Joop is actually asking is how do you form I do have it written somewhere, but let's say, how do you form the expectations of today of the agents of a variable J periods into the future? So the way to do it is you always keep that matrix fixed, because expectations in time T means that you're taking your previous understanding of the world. So your matrix stays the same. So you always keep the matrix the same, but you just forecast the exogenous variables. And you're saying, all right, if I want to get my expectation today of the output gap of T plus J, I need to forecast Z T plus J. Now, it's very simple to do for the exogenous variables, but for the interest rate, you have to run the whole machinery of, all right, I forecast the shadow rate step by step, then I truncate it in order to get the interest rate. But I always keep track of the shadow rate. So the shadow rate always enters here when they're talking about the interest rate, and the final interest rate, they truncate. Does that answer your question? So you're iterating one step at a time, you're getting a full sequence of interest rates. You're saying, all right, if I'm forecasting the shadow rate, I'm going to use the shadow rate in that vector Z, so it becomes an S. But if I'm going to be forecasting output gap and inflation, I'll actually use actual prices, realized prices, meaning the actual expected interest rate, which is truncated at zero lower bound. But in order to get that, you need to forecast first sequence of interest rates, and then you have the states vector, and based on that, you can always multiply by the matrix to get your expectation.
Yeah, so even if you truncate then for a particular period, if you want to calculate the next period in the state vector, you use the shadow rate, if I understand.
Exactly. For the interest rate, you use the shadow rate, you truncate. For the actual output gap and inflation, you use the actual interest rate, because that's what matters in the economy.
Yeah. Okay, thank you.
Yeah, that's, I mean, admittedly, that whole algorithm is not standard learning. That's something that I had to put on it to accommodate the zero lower bound and the forward guidance. You see how that works out in a second. Okay, so we established, so here's the timing. The agents, they see the shocks at any given period. They have their beliefs and they can forecast endogenous variables in the way that we just discussed. The central bank takes those endogenous variables, puts them into the law of motion, which is this, puts the expectations here, gets output gap and inflation, and applies the Taylor rule. This happens at this stage here. The agents observe the realizations and they compare them to their expectations. They do the regular learning, which is mean squared forecast error, and they update their transition matrix. Next period, they see the next shocks, and on and on and on. Now, critically, the central bank never changes the Taylor rule. So you see how the disagreement comes in a second. So the main proposition of the paper is, first, the zero lower bound causes output gap and inflation to be lower for a given shock. Now, the agents expect, they understand the model, let's say in the great moderation, they have a linear model in mind. The zero lower bound is a kink, it's a non-linearity. And I'm saying here, that thing causes inflation output gap to be worse than expected by the agents. And also it means that for a given, meaning that the interest rate would be higher than the agents expect, actually lower than the agents expect, because output gap and inflation will be lower. That implies that they always expect a higher shadow rate than the bank and an earlier liftoff. So I understand that's a bit confusing. So let's try to work out through a really simple intuition of how the proof works, because that's something that I prove analytically. So it can be shown that once you start plugging in all the expectations into these, so all the phi matrices and the z's, you can get the output gap or inflation, just focusing on one of them here, as a function of the shocks and this object, which is the discounted sum of future interest rates expected by the agents, mind you. Now, if we break that down, this is the same sum, and this sum is equal to the entire future expected sum of discounted shadow rates corrected for the censoring. Now, how does the censoring work? Well, if you expect zero lower bound to bind between t plus n to t plus n, so t plus n plus 1 would be already above the zero lower bound, meaning that you have to subtract the shadow rates at that point and you just add the zero lower bound. So the agents in that sense understand. They forecast the shadow rate, but they truncate it, and that enters their expectations. Now, without any zero lower bound, or if you will, in normal times, the learning algorithm ensures that the expectation of the agent, which is just this is a row in the matrix, which is corresponds to output gap, is equal to the realizations. So that in that sense, the learning converges to rational expectations. However, the censoring changes the response of output gap to Z for any given shock. And I show that the way that it changes it is such that the shocks hit harder. Again, that's intuition that we've always had, that when the zero lower bound binds, you cannot accommodate the shock all the way. So meaning for a given shock, output gap is lower than you would have thought. Now, why do the agents get output gap and inflation wrong? Well, in here, they understand this bit. So they understand that the interest rate would be truncated at zero. However, they don't understand this bit, that this bit changes. What is this bit? Well, these are the rows of the transitional matrix which map the shocks to output gap and inflation. Why do they change? Because of the zero lower bound. Now, the agents only update this observationally. So I can tell them, look, forecast the interest rate and truncate it. Use that for your forecast of output gap and inflation. So I try to make them as clever as possible, as well understanding the zero lower bound as possible. And yet they don't appreciate that actually the transition matrix changes because of the zero lower bound. If you will, if you work with the OCBIN framework, the occasionally binding solution, it almost gives, there you have a piecewise linear solution at the zero lower bound. So that's almost like what's happening here. The agents don't understand that the linear solution changes piecewise, step by step along the zero lower bound. They only update it as they observe. So if I show you a simulation. And again, I'm avoiding inflation here just for the sake of clarity. So what we have is a shock, and the black line is the actual realizations of output gap and interest rate. The red dashed line is what the agents expect. I think that's their nowcast. So these are not forecasts, but nowcasts. In period 6, they expect this, but they observe that. So what we see is that they always expect an early liftoff than the bank, which has model consistent expectations and knows that the shadow rate goes down. And that's, that's roughly what, 4 to 5 quarters. Now, this is nice, and this is exactly what I was talking about, that zero lower bound creates this disagreement. But the interesting bit, I think, is that this is actually a compression of a lot of simulations. We're talking thousands here, Monte Carlo simulations. Why? Well, because I can give them a shock, but the agents, the way they're learning, they need some variability. And if the shock just dies out, no learning really occurs. So if I show you an example of one of those simulations which comprise this matrix, so the initial shock is always the same, but then there is a sequence of shocks in all simulations which are averaged out to 0. So what you see here is the disagreement going haywire at some point. And that's the instability that I was referring to. It doesn't always happen. As I said, I'm working on the heat maps, understanding what's the perfect storm which kicks you off and completely makes the system unstable. But let's try to get some intuition of what's going on here. So the agents expect an earlier liftoff. It doesn't happen. So at that point, let's say that's period 10. They expect a positive interest rate, or at least above the zero lower bound. They don't see one. So before that, they expected zero lower bound. They saw the zero lower bound. Even though they were wrong on the shadow rate, here their shadow rate is not as deep as the central banks. They don't see that. They don't correct for that expectation error. They only start correcting once they see that their expectation is diverging from the actual realization. So that's the no communication scenario. Now, yeah, please.
Why are they wrong on the shadow rate?
Why are they wrong on the shadow rate?
Yeah.
Yeah, well, maybe I didn't do a great job on that. So
I'm sorry.
No. I understand it. It's. I'm sorry, it doesn't have a fantastic intuitive explanation, but it's all in the numbers. So the way it works is they forecast the shadow rate using this matrix, or at least the row which corresponds to the
So they use the full matrix.
Well, they use the row. They have 5 coefficients which map these 5 state variables to the shadow rate. And they always do that, and they continue doing it. They do the same for the output gap, the different row of the matrix, same for the inflation. Okay,
so what understood is that it was the part on the output gap and inflation that they would not update, but the one for the shadow rate that they would.
No, okay.
Okay.
So actually it's the other way around. They always update the matrix for output gap and inflation because they always observe them. So as you can see here, if I go back, you can see that they converge. And if I show you the coefficients, which I haven't put in the presentation, but I have a lot of, you can see, all the coefficients of that matrix and how they immediately move when it comes to output gap and inflation. However, on the interest rate, they don't update them. Why? Well, because they observe zero lower bound, they expect zero lower bound, they see zero lower bound. So there's no error. There's no expectational error. However, there is. It's just on the shadow rate, which they don't see. All right. So in that sense, I allow them to put the zero lower bound here. So they can get a little bit closer to output gap and inflation forecast. Why don't they go all the way? Well, because it turns out that the zero lower bound here changes the coefficients of this matrix when it comes to output gap and inflation. You can think of it, a given minus 5% natural rate shock now hits harder. Why does it hit harder? Because the zero lower bound doesn't allow us to accommodate it with monetary policy. Can the agents account for it? Only observationally. Only once they make a mistake. They make a mistake and they see, oh, I'm off, so let me update my coefficients. but they cannot foresee the structural change that the zero lower bound does on the law of motion of output gap and inflation. Is this a little bit clearer or? Okay. So this particular disagreement here causes them to load up on the persistence of the interest rate. So the interest rate, you know, Korbon and Gornichenko, they run a lot of estimations on that, but let's say it's around 0.8, between 0.7 and 0.85. You can see we're already pretty close to a unit root, which is dangerous territory when you're talking about iterating expectations forward. So what they start doing here is loading up on that perceived persistence, because they see the shocks and they're saying, well, the shocks are not driving this. Why is it staying persistent? And they perceive the interest rate as more persistent as it actually is. They run their forecasts forward. The central bank sees that and says, oh, wait a second, these guys are expecting something wrong. So I better, they're expecting very low interest rates because they've seen low. I mean, we're not talking zero lower bound, but lower than I would like. So they start increasing the interest rate as they do to counteract that. And this creates this kind of helix pattern where the agents at this point, let's say quarter 15, they expect some interest rate to be lower, but then they see it's keeping up and up and up, which again, they keep loading up on the persistence. And in the end, if I just show you what it looks like, is something like this. So this is the perceived, sorry, this here is the perceived persistence of the interest rate by the agents. And you can see that around after the zero lower bound, it starts drifting up. And if no communication is in place, it gets ballistic at some point. Now, as I said, it depends on the perfect storm of the shocks. And that's something that I'm working on to clarify. So if you look at the expectations of the zero lower bound of the agents and the bank period by period, so then you ask them, period 0, what's your expectation of the zero lower bound? Still not binding, so we don't do anything. Period 3 is there, and so on and so on. When does it end? How long is it going to last, the zero lower bound? And what we see is that the agents always expect a lower expectation, sooner liftoff than the bank. The simple forward guidance that I'll consider in this paper is just the bank tells you, wait a second, you're wrong. Here is the date that I expect. Nothing strategic. They're not thinking about how are they going to change your expectations. They're not committing. They're just acting like the Bank of Sweden, every period releasing the truthful forecasts of when the zero lower bound is going to lift. As I said in a different paper, I consider how is it perceived, but here let's just say the agents take it as given and they incorporate it. So essentially in their forecasts here, once they get the forward guidance message, they say, oh, I know from period M to period N, we're at the zero lower bound. So I'm going to truncate it at the zero lower bound. They still keep track of their shadow rate, but they put a kink that the central bank communicated. Now, if I show you.
But then even if their shadow rate is positive, they expect a zero interest rate.
Yeah, exactly. So if you want to get a little bit more technical, what happens here is they don't change their law of motion of the interest rate because they see zero lower bound, they expect it. They don't update on the interest rate, but they take the central bank's word as given just for the kink. So essentially once you lift off, let's say here they've received the message, once they lift off, they'll still disagree because these guys expected the interest rate to behave when it comes to the shocks, how the shocks map into the interest rate, and that works throughout the rapid inflation. They expected it to be just like before the zero lower bound. While the bank knows the structural model, knows there's persistent, and it takes a little while to get back there. But the key takeaway is that the disagreement is much lower. And that simple act of just telling the people when you expect the zero lower bound to be lifted. Yes, it doesn't completely eliminate disagreement, and you can be more sophisticated. You can give them the whole trajectory. So you let them learn. But even if you consider just the period, which is what I do here, essentially you keep the disagreement within the basin of attraction of the learning model. And you are working around this instability that happens due to the kink. So that's something that you can't really prove analytically with these learning models. What you can definitely say is that if you if the king stays forever, it's not learnable. That's what the literature has done. But what I hope to show you here is that using such a simple policy tool as just telling them when you expect the liftoff and why should you disagree in the first place, you can keep your disagreement in check such that the learning doesn't explode. Now, the more savvy among you when it comes to adaptive learning would say, well, there is this thing called projection facility, which essentially is a little dirty trick that the literature uses to say, look, we're going to imply on the agents that they stay below unit roots. We don't allow them to go to a unit root for any variable because it goes bananas. And actually, I do impose that, and it does help with stability. It doesn't, however, eliminate the full story. So if I show you, for instance, on the x-axis, we have the Taylor rule inertia coefficient, rho I. And on the y-axis, we have the implied empirical persistence of the interest rate in the phi matrix. And the shaded area are the common estimates. So you can see that we have very tight bounds to work with. We have 0.6 to, and this is what we impose the projection facility on, because that's what the agents learn about, the empirical bit, not the policy bit. So we have 0.6 to 0.75, something like that. So even if I restrict them and I don't allow them to go into that territory, by spuriously updating their expectations, they still drift on a bunch of other parameters. Let's say how the natural rate shock hits, how the cost push shock hits, output gap inflation and interest rate, which then, as I said, given the perfect storm of shocks, makes the system unstable. So the next step is really to get these heat maps showing you what are the most likely combinations of shocks which destabilize the system, and perhaps give us an idea when should you intervene with forward guidance and when you can just let it be. All right, so quickly, just to sum up, we've developed a very simple model of disagreement between the bank and the agents about the policy rate, showing that the zero lower bound plus disagreement which it causes create instability, and that forward guidance can be a very simple and effective way to stabilize the economy by keeping the agent's disagreement within the basin of attraction. All right, well, if somebody has any questions, oh, Carlos, I'm sorry, you should have popped in if you wanted to ask.
Yes. Sorry, Viktor. I wanted to make some comments about your paper. Well, it would be a lot of work, what I am suggesting, but perhaps for a future agenda. You know that, well, now there is all this empirical literature studying the expectations of different firms, and therefore there is this agreement among firms. And, well, then there is also that literature about the granular macroeconomics, because some firms are larger and they can command the cycle, other firms are smaller. So I was thinking, well, for very large firms, it's probably very likely that they are very informed about inflation and they act like the agents in your model. Because I assume, I don't know, Amazon, the very big firms, they all know inflation and they make sophisticated inflation projections. But it seems for the smaller firms in the survey data, what they report is actually they think inflation is similar to the costs they themselves face. Like they have their own wages, their own costs, and they think aggregate inflation behaves like their own idiosyncratic shocks. So I was thinking maybe for a future work, a future agenda, you could try to exploit that. And maybe it would be an interesting paper. For households, I guess there is a lot of heterogeneity, but it is hard to interpret because you get these people, they always report 10% inflation, even if it hasn't happened. So the median household seems to have an adaptive expectations, but outside of the median, we just don't understand very well what's happening because there are these people with crazy expectations. But maybe for firms, it can buy you something for a more sophisticated model.
Yeah, I completely agree. Now, heterogeneity is incredibly important. And that actually reminds me of something we discussed earlier with Joop about the heterogeneity and the fact that you could have informed and non-informed agents, and which one matter for the economy more? Is it a SPF or is it just household forecasts? And as you said, some people don't really understand what inflation is. I definitely agree these are important topics, and they could inform how central banks communicate. Yeah, indeed. Whether then there is, I think there is a push to central banks targeting more and more of the layperson in their, let's say, social media, or things like more simplified communication, because perhaps when they, if it's more technical, like you said, it's really hitting those more informed people anyway. Yeah, it's something to consider indeed. Yeah. Okay.
I have another question. Could
Yeah,
you
please.
show again the graph with the like where you have the average, where the noise is cancelled out, basically?
Here.
Uh-huh.
Yeah.
So okay, yeah, because like here it is just more smooth, but otherwise the idea is the same as in the other graph, or like, can you
This is
can
the
you comment a
average.
little bit on how this relates to the example that you gave?
Okay, so let's say I'm running this simulation 1,000 or 100,000 times. What I'm showing you here are the average, or I should say, I think it was the median, because obviously, you know, as Laura was kind of hinting, the zero lower bound messes this up. The median of the non-explosive economies. So I'm running 100,000 economies with the same initial shock, the same starting conditions of, let's say, the great moderation. They understand the economy, they've converged to rational expectations. And then I'm hitting each economy with a bunch of different shocks because I need the learners to have some variability to learn from. And depending, and this is just, this picture here is the median of the non-explosive ones. Now, I guess if you run them for, you know, depending how long you run them, you can always find someone that explodes because you just get the perfect storm. But I can't remember, I think I ran them for 500 or 1,000 periods. Does this answer your question?
Yes, so, but the other one that you showed is a non-explosive one or an explosive?
This one?
Yeah.
No, this one is explosive. You can see I haven't run it because then it just, I haven't
okay,
shown
so
it.
later it becomes explosive.
Yeah. I mean, already here, and this is, I think that's from there. If I think that's from that economy, that you can see already the perceived persistence of the interest rate is way above 1. And once you start iterating, it just goes ballistic. So
yeah, I think it's a very interesting mechanism that you have here. So I think it's intuitive that like when you're at the zero lower bound, you cannot learn about this. So it's nice to.
yeah, that bit is intuitive, but the disagreement bit I definitely need to make more so. Yeah.
Yeah, but no, I like this extension of that.
Yeah, and as I said, I was happy to see that in your lab, people still exploded their expectations, which give it a bit more validation of that little story.
That's great, thanks.
All right, any other questions? Okay, great.